For number 1, what are they all decreasing by? They're decreasing by -4, so that's consistent. So I know it's going to be -4n, and then we're going to have to add or subtract something. So remember, 7 is the first term, and number 1 is what you plug in for the letter n. So 4 times -1 is -4. So what would we have to add to get a 7? We would have to add 11. And we can spot check it. So 3 is the second term, so -4 times 2 for the second term is -8. And then -8 plus 11, of course, is +3. So I'm solid. I know that's the expression. Make sure you understand, if I take this expression and set it equal to a sub n, this is called function form. And you need to know that, so you should write that down. That's function form. Let's talk about the bottom one, the recursive formula. Again, you find how they're changing, and they're all changing by the same thing. They're all decreasing by 3. Now remember, the recursive formula is all about the next term, so I always start with n plus 1. So it is the next term, and that's going to equal the now term minus 3. So that's the recursive formula. It's the next term based on the current term. So if I'm right now on the first term, my first term is 14. Once I take 14 and subtract it, I get the next term. Once I take 11 and subtract it, I get the next term. So this is the recursive. Ooh. Yeah, that's how you spell recursive, kind of. All right, let's go back and review factorial. So please go to page 2. You actually have done factorial a long time ago when y'all were little junior high kids. Nope, that's not page 2. Here's page 2. All right, so here's what factorial is, guys. On number 9, the top where it says 10 factorial, it is literally 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So let's go ahead and expand it out. So the numerator is going to look like this. The denominator is going to be 2 factorial, which is 2 times 1, times 8 factorial, 8 all the way down. So that's what it looks like, but it actually cleans up a lot, because remember, when you have a number being multiplied and a number on top and bottom being multiplied, they cancel. So all the 8 down cancels. So what you're left over with is 9 times 10, which is 90, divided by 2 times 1, which is 2, but of course you got to simplify everything. So the final answer is 45. That's what factorial is. Now starting with problem 10 on, I'm going to kind of shorten how I write this. Look at problem 10. So problem 10 says 6 factorial at the top. Y'all remember that's 6 times 5 times 4 all the way down. So if I write 6 times 5 and then write a 4 factorial on the top, that's going to be the same as 6 factorial. And the reason why I wrote it like that is because these 4 factorials are going to cancel out. So what you're really ended up with is 6 times 5 over 3 factorial. That's 3 times 2 times 1. So that's going to be 30 over 3 times 2 times 1 is 6. So that is going to simplify to 5. And that's really how we need to write it. We need to write the highest factorial in terms of the next highest factorial, because they're going to cancel out. So for problem 11, I'm going to leave 5 factorial and 2 factorial for a moment. But remember, 7 factorial is going to be 7 times 6 times 5 factorial. It's the same thing. So these 5 factorials are going to cancel. So I'm going to be left with 2 factorial. That's just 2 times 1. Over 7 times 6, that's 42. Y'all, this is 2 over 42, but you can't box that in. Remember, you got to simplify everything. So the answer for number 11 is 1 over 21. All right, so that is factorial, but for us, y'all, in pre-cal, it's mostly going to have in terms of n. So if you automatically, immediately recognize what the answer is, feel free to write it. I'm always going to sub in a number. That way we can all conceptualize what the answer is. Every time I see the letter N, I don't know why, but I always let it be 7. So I'm just going to pick a random, it's not random, I'm going to pick 7. So if N is 7, then the top is going to be 7 factorial, and N plus 1 is going to be 8, so 8 factorial is going to be underneath. But remember, if it's 7 factorial at the top, I can rewrite 8 factorial as 8 times 7 factorial. So these cancel. Remember your fractions, when everything cancels out on top, it's a 1. Y'all, that simplifies to 1 over 8. But if it was written in terms of n, we have to put it back in terms of n. So the answer is going to be 1 over, how did we get that 8? We got that 8 from n plus 1. We let n be 7, and we got the 8 because we did n plus 1. So 8 is n plus 1. Let's do it a couple more times with the letter N. Y'all turn to page 4. Please turn to page 4. I'm going to find my page 4. Here it is. All right, at the bottom of page 4, y'all, I'm just going to do 69 and 71, just the ones in terms of N. And y'all, I'm still going to let N be 7 just because I'm consistent. Just picking the random number. I just picked 7 because I like 7. So if I choose 7, then the top is going to be 8 factorial over 7 factorial. Y'all, 69 is the reciprocal of the problem we just did. So I can rewrite 8 factorial as 8 times 7 factorial over 7 factorial. So those are going to cancel out. So this time it's a whole number 8. But again, how did I get 8? I got it from n plus 1. So the answer is n plus 1. Let's do it again. N is going to be 7 again. So on 71, 2 times 7 minus 1, that's going to be 13 factorial on top. 2 times 7 plus 1 is 15, so 15 factorial on the bottom. All right, let's keep 13 factorial on the top, but on the bottom, let's do 15 times 14, then times 13 factorial. So again, those are going to cancel, which is totally awesome. Don't multiply 14 times 15, because remember, we have to write it in terms of n. So everything canceled out on the top, so it's going to be a 1 on the top. And then how did we get the 15? We got the 15 by 2n plus 1. 15 is 2n plus 1. What's 14 doing? Just 10. That's the answer. With sigma notation. For sigma notation, your answer is always going to be a single sum, a single number. That sigma symbol, that always means adding. That's like a universal addition sign. And we are going to add where it tells me to start and where it tells me to stop. The bottom number tells me where to start. The top number tells me where to stop. So it looks really crazy complicated, but it's not complicated at all. All right, so here we go with number 1. 1 through 3, we're just going to get comfortable with sigma notation. Number 4 is going to be adding an infinite series, which we can actually do. Number 6 should kind of be grouped with 1 through 3, and you'll see why I say that. And then 7 and 8, we're actually going to write the sigma notation, the rule for it. All right, so let's go back to number 1 and get started. Okay, find the sum. We will. Where are we going to start? On the first term. Where are we going to add to? To the fourth term. So we're going to kind of have to write small. So let's write a sub 1, a sub 2, all the way down to where it tells me to stop, which is a sub 4. And remember, with these sequences, the subscripts are the inputs for the letter. So that 3i, that's going to be 3 times 1 plus 1. Then 3 times 2 plus 1. 3 times 3. All right, and once we do our order of operation, those are the terms. Here we go. So the first term in this sequence is 4. The next term is 7. Next term 10, and then 13. And then, y'all, we just add these up. Just add them up. Turn on your calculator, do 4 plus 7 plus 10 plus 3. All right, so notice I had 4 rows here. On problem 2, I'm going to have 6 rows, even though it says to stop at 5 because we're starting at 0 this time. So let's do a sub 0 all the way down to a sub 5. Just remember to plug in those subscripts as the letter N. Don't forget your order of operations. You're going to square this stuff first, then times 2, then minus 3. All right, here we go. So 0 squared, of course, is 0. 0 times 2 is 0. So my first number is negative 3. My next number is going to be 2 minus 3, so that's negative also. This is going to be 8 minus 3. It's going to be 9 times 2. It's going to be 18 minus 3. 16 times 2 is 32. So 32 minus 3 is 29. And this is going to be 47. So again, guys, please add those up. You should get 92. Add them up. Make sure you get 92 because that's the answer. And we're going to practice this one more time before we kind of level up a little bit. All right, for number 3, we are starting at a sub 3. We're going to stop at a sub 6. And guys, we're just squaring these and then adding them up. So we're going to do 9 plus 16 plus 25 plus 36. And you guys should get 86 when you add these up. All these add up to 86. Ooh. All right, part 4. All right, y'all. So we are going to actually add up an infinite series here. It's just a pattern, you'll see. It's going to turn into a fraction. All right. So this goes on forever. Note the infinity symbol at the top. Let's just start exploring what the first few terms look like and see if we identify a pattern. So this is going to be 1 over 10 to the first term, so that's 1 over 10. That's the first term. The second term is going to be 1 over 10 squared. Third term is going to be 1 over 10 to the third. So this is like 1/10 plus 1/100th plus 1,000th. Like this. 1/10 plus 1/100th plus 1,000th. Y'all turn on your calculator. Let's add these up. All right, so 0.1 plus 0.01 plus 0.001 plus. Hit enter. Ooh, hold on. I accidentally had an extra plus sign. Let me delete that. Now let me hit enter. All right, so if you notice, guys, it's 0.1111 repeating forever and ever and ever. And usually every time you have a repeating decimal, it's a fraction. So if you do not remember how to do the conversion from a decimal to a fraction, you might want to write it down. Remember, it's the PRB button right here. See the FD? See how it's in yellow? You're going to have to hit the yellow key first. But, y'all, if I did it right now with only 3 ones, that can be simplified. So let me clear this out. Put 0.111 a whole bunch of times, like a ridiculous amount. Fill up the whole screen with ones. And then hit your second PRB and hit enter. So 0.1 is 1/9 repeating. That's how you're going to have to approach these infinite sums. So let's write this as 1/9. That's the answer. Anytime you have a repeating, you convert it to a fraction, that's going to be the answer. This needs to be in fraction form. All right, let's do it again. Let's look at number 5. So number 5 is an infinite series of 5 over 10 to the I. 5 over 10 to the I, y'all, is the same as this. 5 times 1 over 10 to the I. You've already done the hard part. You know what this is. You just did it. So this is going to turn into 5 times 1/9. So this infinite sum is 5/9. Any questions on that? All right, let's look at number 6. So y'all, number 6 says an infinite sum. It does, because of that infinity symbol. But look at the directions. It says find the fifth partial sum. It is just like this. It's just like there's a 5 at the top. So it can be grouped with 1 through 3. So as you're working through this unit, make sure you read the words, because even though it says infinity, you might be finding the infinite sum or you might be finding partial. So we're going to find partial here. So x represents the term in the series. We're only going from 1 through 5. So this is going to be 10 times, here's your first term, 1 over 1. Your second term is 1 over 2. It's a half. Oh, I should write a plus sign, not a comma. That should be a plus sign because we're adding. Third term is 1/3. Fourth term is 1/4. Fifth term is 1/5. All right, we're going to have to add these fractions, which means we are going to have to find a common denominator. Let's do that now. So, guys, a common denominator of 1, 2, 3, 4, and 5 is 60. So we're going to write all these as 60s. Y'all in pre-cal, y'all can totally handle that. All right, 1 over 1 in terms of 60 is 60 over 60. There's your whole number. What's half of 60? You know that. It's 30 over 60. What's 1/3 of 60? What's 60 divided by 3? It's 20. So 1/3 is 20 over 60. What's 60 cut into fourths? What's 60 divided by 4? It's 15. So this is 15 over 60. And guys, if you did 60 divided by 5, you'd get 12. So this is 12 over 60. So let's turn on that calculator. Do 60 plus 30 plus 20 plus 15 plus 12. Only add the numerators. Remember, you don't add the denominators on fractions. So when you, excuse me, when you add all these up, you get 137 over 60. But remember, it's being multiplied by 10. And y'all, remember 60 is 6 times 10. So you have a 10 on top and a 10 on bottom. So that's going to be 137 over 6. And that's the answer. Not hard. This is probably the easiest now that you know this stuff. 7 and 8, we're going to write the rule. So we are going to draw this fun little symbol right here. And you're just going to notice what is exactly the same every time and then what is changing, guys. So if you notice, the 5s are staying consistent. This 1 in front is staying consistent. So what's changing are those numbers right there, and they're changing in sequential order. So that means n is going to start at 1 and it's going to stop at 15. So put a 15 at the top. Then you're going to write exactly what stays the same. So we're going to write 5 over 1 plus. And remember, what's changing sequentially is the letter n. So this is an n. And that's it. That's how you write that rule. Let's try number 8. All right, so for problem 8, what is changing? The numerator. Looks like we're starting at 1 again, but this time we're only adding up through the 6th term. So let's draw our sigma notation again. We're going to let n equal 1 because that's where it starts. But it stops at 6, so let's write 6 at the top. And again, guys, you're going to draw it exactly how it's written. Keep everything the same that doesn't change. But what does change, you're just going to put the letter in. So it's just going to look like that.